All right, so we're starting up on page 2 now. This is going to be mostly graphing, but we do have to solve some stuff. We have to solve for the vertex, the x and the y intercepts, and that where applicable part means like if you have x-intercepts, there will always be a y-intercept and always be a vertex. And also if there's a stretch. In other words, if there's some sort of a multiplying number in front of your x squared. And then after that, we have some imaginary numbers that we're going to be working with as well, some complex addition, subtraction, multiplication, and so on. All right, so for number 14, we're going to sketch the graph of each of the functions and then state the vertex and all transformations used. Well, we're going to be able to find the vertex really easily because this is in vertex form. Vertex form looks like this. Y is equal to a times parentheses x minus h squared plus k, where the h and the k value give you the vertex. So really easily, you can find the vertex by just taking the opposite of the number that's adding or subtracting on the inside. So the opposite of positive 4 is a negative 4, so our vertex x value is a negative 4. And then whatever is adding or subtracting outside. So in this case, it's 1, so the y value is 1. So just like that, we have the vertex of the graph. When it's in vertex form, it's pretty easy to find. Just the opposite of the number in the parentheses, and then exactly the number that's outside the parentheses, so negative 4, 1 in this case. And then we graph it out. Left 4, up 1, there's our vertex. And through the vertex, we have an axis of symmetry, a mirroring line that we can use to graph out the entire thing. So let's go to a t-chart. Really easy to use a t-chart. Negative 4, 1 should be the first coordinate that you put up there. And then for the other coordinates, just to get a couple more coordinates to graph it out and make it look pretty accurate, we can just go ahead and add a couple of numbers onto our x value. So if I have negative 4, and if I go up 1 more, I get to negative 3. And if I go up 1 more, I get to negative 2. So those are the two numbers that I'm going to plug in to my calculator. So let's plug it into the calculator and see what we get. So we have 2 times parentheses, and then negative 3 for our x value, so negative 3, plus 4, so plus 4, and then end the parentheses, and then square it, and then plus 1 at the very end, so plus 1. If I hit enter, I get my y value. So when I plug in negative 3 for x, I get a positive 3 for my y value. So that gives me another coordinate, left 3, up 3. And remember, from this axis of symmetry, I can reflect it over and find another coordinate. Do you already see the U shape starting to form for the parabola there? Let's get one more coordinate, negative 2. So if I plugged in negative 2 for the x value, I could just type it in. Or if I have one of these fancy TI-84s or TI-83s, I can hit the button, the second button up here in the left-hand corner, and then this button down here, enter, and that will rewrite what I just wrote in, and I can just scroll over using the arrows and change that 3 to a 2, because that's the only thing that I'm changing, just changing the negative 3 to a negative 2. So if I hit enter, it gives me the other y value there, negative 2, 9. So if I go to the left 2, negative 2, and then up 9, there's my coordinate, and I can reflect it over to here. So there's my parabola. That's how we accurately graph it. And then, of course, you can always graph it out on your calculator. If you want to double check it, you can hit y equals and then type it in as it's seen. So 2 parentheses x plus 4 and then squared. Use the square button and then plus 1. And if you hit the graph button in the upper right corner, it graphs it out for you. See, there it is. Same graph that we have right here. Okay, next we need to write out all the transformations that we see on our graph. So those are all pretty easy. Transformations look like this. So if we have y is equal to a times parentheses x plus h, or I'm sorry, I better keep it the same that it's written up there. So minus h squared plus k. Okay, so here's how you can tell where you have the different transformations. If you're adding or subtracting inside the parentheses, then if you're adding some number, then that means that you're moving to the left by whatever that number is. If you're subtracting inside the parentheses, then you're moving to the right by that number, whatever it is. Okay, so if we go back over to here to our original equation, we're adding by 4 inside the parentheses, so we're moving to the left by 4. So that's one of my transformations that I can list off. We're moving to the left by 4. All right, another transformation that can happen is if you're adding or subtracting some number outside the parentheses. So if we're adding some number, we're moving the whole graph up by whatever that number is. If we're subtracting by some number, we're moving down by whatever that graphing number is. Okay, so if we have a plus 1 outside the parentheses, that means that we're moving up by 1. So that's another transformation that we can write down, that we went up by 1. The last thing that affects it is this a value over here. So there are a couple things that can happen. If a is negative, then that means we have a reflection, and the reflection will take place over the x-axis. So if you see that, know that that's one of the transformations that you can see. Another thing is that if that a value is greater than 1, so if it's 3 or 4 or 5 or 1.8 or whatever, then that means that you have something called a vertical stretch. And if our a value is a number that's between 1 and 0, then that means that we have instead something called a vertical compression. And I'm sure that your teacher will be fine if you wrote VS for vertical stretch or VC for vertical compression, because that's what they are. In this case, since we have a 2 that's multiplying out front there, then that means that it's going to be a vertical stretch because that's greater than 1. So we have a vertical stretch, and usually what we like to do is say that it's of a factor of 2. So I just put parentheses 2 right next to it to signify that. So these are the list of our transformations, those 3, and this is our vertex, and we're all done with number 14. 15 and 16 are a little bit easier just because, we practice finding the vertex, the x and the y intercepts for all these. Let's just check for stretches real quick. So a vertical stretch happens if you have a 2 or a 3 or a 4 that's multiplying on your x squared. We don't have one here, but we do have one here. So there's our vertical stretch of 2 on number 16. So, it's pretty easy to spot. Let's graph these out. So we always start with the vertex and then do a little t-chart surrounding it. So to find the vertex when it's in standard form, like these two, instead of in vertex form like this, what we do is we list off the a, the b, and the c values, and then we recognize that for the vertex, the x value is always going to be negative b over 2a, and then the y value, we just simply plug in the x value to find the y value. So the a, the b, the c for this one. So a is equal to negative 1 because that's on the x squared. B is equal to 2 because that's on the x, and there's no constant value, so that means that our c value is equal to 0. Similarly for this one, our a value is going to be equal to 2, our b value is going to be equal to 8, and our c value is equal to 5. So we use the formula and find the vertex. So negative b over 2a. All right, so b is going to be 2, so we have negative 2 over 2 times a. A is negative 1. So negative 2 over negative 2 gives us a positive 1. So our vertex is going to start with an x value of 1, and we need to find the corresponding y value. So to find the y value, we plug it into the equation. All right, so we can use our calculator for that pretty easily. All right, the negative of 1 squared, and then plus 2 times 1, and we get 1. Okay, so 1, 1 is our vertex, so I go over 1, up 1 to graph it. And through the vertex, I get the axis of symmetry. And so I can start graphing some coordinates to go along with this. So here's my t-chart, my x and my y. I start off with my vertex 1, 1. And then for the x values, I go up by 1 and up by 1 more. So up to 2 and then up to 3. And I plug those numbers into the equation as well. Well, I can still use my calculator and plug those in pretty easily. I just hit second enter, and then I change those 1s to 2s. And then hit enter, and I get 0. So 0 is going to be my coordinate when x is 2, so go over 2 up 0. And you know what else is really nice about this? We just found one of the x-intercepts. It goes directly through 2, 0. So there's one of our x-intercepts that we can list off. So if this is our vertex, our x-intercept, so far one of them is going to be 2, 0. And the other thing is that we can reflect it over this line, over the axis of symmetry, and we found our other x-intercept. It's located right over here at 0, 0, the origin. So we have another x-intercept at 0, 0. And another nice thing about this, it just keeps getting better, this is also where it passes through the y-axis. So this is going to be our y-intercept, 0, 0, once again. So really nice. And plus, we're almost done with our graph. Let's plug in 3 now. So second enter, and then change those 2s to 3s. And there we go, negative 3. So 3 over 3 and then down 3. 1, 2, 3. And then reflect it over the axis of symmetry. So that's 2 away. So 2 more goes right there. And you see the U shape, or I guess it looks like a lowercase n in this case. And there's our parabola for number 15. Number 16. So we've got our a, b, and c values. So let's find the vertex again. Negative b over 2a. So negative of 8 over 2a. So 2 times 2. We get negative 8 over 4. And then negative 8 over 4 gives us a negative 2. So negative 2 is the x value for our vertex. Let's find our y value. So we're going to plug negative 2 in for x here. All right, so here we go. 2 times parentheses negative 2 squared. And then plus 8 times parentheses negative 2. And then plus 5. All right, hit enter, and there's your y value, negative 3. So go to the left 2 and then down 3. There's the vertex. And through the vertex, you get the axis of symmetry. Now let's find a couple more coordinates to graph this out. Maybe we'll get lucky and get more x-intercepts or y-intercepts. So if we start at negative 2, negative 3, go up by 1, that gets you to negative 1. Go up by 1 more, and that gets you to 0. So I'm going to plug in negative 1 and 0 for my x values. And when I plug in 0 for x, that's going to automatically give me my y-intercept. So whatever that is, that's going to be my y-intercept when I plug in 0 for x. Okay, so let's plug in negative 1 first. So hit second enter, and then change those negative 2's to negative 1's. Hit enter, and you get negative 1. So negative 1 is our next coordinate. So go left 1 up, left 1 down 1. I almost made a mistake there. There we go. And then reflect it over that line of symmetry, and we've got another coordinate. Now let's plug in 0. So we hit second enter again and change those negative 1's to 0's. All right, so 0 there. And I hit delete to get rid of the negative there, so 0, and I get 5. So 0, 5 is going to be my y-intercept. So over 0 up to 5, and then there's our parabola. So that's all graphed out. It looks like the x-intercepts are going to be somewhere in here. I don't have those numbers yet, so what I'm going to do is find it the easiest way that I know how, and that's by using the quadratic formula, unless you want to factor. It doesn't look like these numbers are going to factor really easily, so just go straight into quadratic formula. So that's what I'm going to do. So 2x squared plus 8x plus 5. I need to list off my a, b, and c values. A equals 2, b equals 8, c equals 5. So plug it into the formula. Negative of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. All right, so we get negative 8. Negative of 8 is negative 8 plus or minus the square root of, and let's do all that in our calculator. So let's see here. 8 squared minus 4 times parentheses 2 times parentheses 5. I get 24, so square root of 24 all over 2 times 2, which is 4. So you know what? I know you can reduce this radical a little bit more, but these are your x values for your x-intercepts. They look kind of nasty, but that's what they are. One of the numbers is going to be negative 8 plus the square root of 24 over 4. The other one is going to be negative 8 minus the square root of 24 over 4. That's just, how it goes. It's just going to be like that sometimes. So those are your x values, and your y values are automatically going to be 0. So let's write them out. Our x-intercepts are going to be negative 8 plus the square root of 24 over 4, comma 0. And then the other one is going to be negative 8 minus the square root of 24 over 4, comma 0. So those are our two x-intercepts for this graph. It doesn't look like it, but that's just what they are. So that's the graphing part of it, and next we're going to start up with the imaginary numbers and do the word problem.